Okay, wonderful. Everybody, thank you all for coming. I'm very excited that we have Scott here. I've been thinking for the last few days about how I'm going to introduce Scott, and I decided that the best way to start is I was praying for 2 years for somebody to come into my life who had exactly Scott's skill set, because what I want to do can't be done without him. And I think that for everything a lot of us are doing, he has a skill set which couldn't be more applicable. I'll let him describe what it is he does, but just to give you a sense of why I thought it was, I'm also working nonstop on creating regenerative agricultural solutions with trying to avoid inputs and channel waste and to create a sovereign food system, as most of you know. John, I don't think you know that. I've worked with animals for many years. I run over 1,000 animals now, and for me, I think that our island should be. I imagine the entire mountain with kids on horseback running multiple species according to GIS mapping and AI generated plans to be able to really improve soil fertility, sequester carbon, and create the best food in the world, not only to feed our people, but for an export market. I think it can be done, but I think that Scott's work on mapping the whole island and creating the opportunity to see how this can be done is really crucial to my thinking. So I'll stop there and I'll introduce Scott, and I'll let him and his presentation speak for itself.
Thank you, Gary. Can everybody hear me?
Yeah.
Okay, I'm going to share my screen now, and hopefully everybody will be able to see it. Okay, does everybody see my screen?
Yes.
Okay, great. So first of all, thanks, Gary, for introducing me and for inviting me, and thanks to all of you for giving me your time. It's great to see that there are some people with geospatial analysis backgrounds, people from the UN. I've also done a lot of work in a lot of countries that people don't know where they are. But if you look at my bio, you might think that I might be talking more about that than anything else, with United Nations Convention on the Law of the Sea and Article 76 with continental shelf mapping. But today I wanted to focus on some of the stuff that I've done in Hawaii for the past 6 or 7 years. And so it's great to hear you have a really broad range of expertise and experiences. So this isn't going to be completely focused on everybody's expertise. This is actually a presentation that I made for the Hawaiian Macadamia Nut Association a couple of years ago when I was working as the orchard technologist for Hawaiian Macadamia Nut Orchards, which is the largest commercial mac nut farm in the state. So what they wanted me to do is to start a drone program for them, but they had no idea what drones could actually do. And I was kind of a little bit taken aback when I found out exactly what level of information they were working with, because I was expecting that I lived in the outer islands. I lived in Micronesia, Samoa, Philippines, all these other places, and you can go to NOAA and you could go to USGS and you find all these wonderful resources, and so I really thought everybody in Hawaii had their act together, right? But then when I came to the commercial mac nut farming industry, I was kind of like, oh, well, what do you guys have? And it wasn't that much. So what I'm going to focus on today is how people can use geospatial technology for their planning, monitoring, and evaluation, and go over some of the different tools that we have. And there's kind of a triangle here that shows I'm working a lot with imagery and analysis, and then also some fieldwork aids. So some of the challenges that I came across in the very beginning was that there was too broad of a scope. There wasn't a whole lot of detail in the maps or the areas that people wanted to focus on. Nothing was really shared amongst even employees of the same orchards. They were just working in silos in different little blocks. There was no baseline information. They didn't know they hadn't updated any of their total, acreage that was in production. They didn't know tree counts. They didn't know anything like that. So I started out small, and then I started going into a little bit more um, with, I like to call it like the sixth sense or a superpower, and I'll explain a little bit more of that later. So I like to break it up into a couple different zones. Zone one is your low level stuff. It's legacy maps, paper maps, graph paper, stuff like that. Zone two, people are starting to use a little bit of satellite imagery or even higher resolution stuff, starting to use some apps on their phones or whatnot to try and assist them in the orchards. But then when you get into zone three, you kind of are, this is where you're getting into the sixth sense, where you're using multispectral imagery to look at data in a way that you can't see with the human eye, but you can tease information out of that kind of data. And, of course, what's coming on scene more now is hyperspectral and LiDAR kind of data. Actually, LiDAR has been around for a long time, but the hyperspectral imagery that's also been around for a long time, but it's becoming more widely used. So this is an example of the zone one. I asked them, where are your maps? And this is what they showed me, this stuff here on the left. And this is what they're using day to day. So I was like, wow, okay, nothing's to scale. There's just a bunch of scribbles on there. You can't tell where north is, any of that. So the first thing I did was just make a couple of updated maps. And this is just basic satellite imagery. I don't remember if it was Sentinel imagery or Landsat, but something that was just a little bit more spatially correct. So then I started flying a drone in these orchards and collecting higher resolution imagery. So you can see on the left, this is the orchards around Kale. This is the Mauna Loa husking plant. And these are all MagNut fields. So you can see the resolution is a little bit pixelated. There's cloud cover. So when you start flying drones, you can get a much better idea of individual plants. And just to demonstrate the difference there, this is a satellite imagery. And then if I kind of swipe that imagery down, you can see the difference between what you're getting from satellite imagery and what you're getting from, drone data. So you can get very, very high resolution and a lot more information out of drone information than you can from satellite imagery. And so then, what you can do with some of that imagery, you turn thousands of photos into what's called an orthomosaic, and it's basically just stitching them all together into one big map. And then you can see on the right-hand side, you can make a big poster-sized map of the whole entire orchard, all in high resolution, like you see here on the left. And so that allows people to really examine what's going on in the orchards and make better decisions that way. One of the other things that I do is I make these 3D kind of panoramics for scouting so that they can look at the orchards in a kind of a panoramic view, more like a sphere. They can zoom in, they can zoom out. They can see if people are dumping cars or, if there's some really bad invasive species areas that they need to clean up, stuff like that. So it's just and this takes, 5 minutes. You can go out there with a drone, put it up, take a series of like 24 photos all in a circle, and then produce something like this in almost no time. And then moving into some of the other stuff, I did mention people use some of the smartphone apps, some things like Map It. Some of them are free, some of them are paid. ArcGIS Field Maps is one that's paid, but it's kind of like, it's sort of an industry standard as far as the commercial side of things go. It's not open source, which is kind of a bummer because it's really popular and a lot of the government agencies use it. I would prefer to have more data sovereignty with open source tools, but this is kind of the one that most people are familiar with using. And when you combine some of those apps with tools like global navigational satellite systems, like this MLID receiver you see on the right on the tripod, you can get pretty accurate data. Sometimes up to 2 to 4 centimeters accuracy, as opposed to on your smartphone you're going to get maybe 13 feet. So if we're looking at the multispectral imagery, if you look at the stuff on the left, that's your visible light spectrum. And you can basically see, it's all it's all green. Some of it might look like you can start to tell there's a little bit of a yellowing or browning. But when you apply non-visible light from the near infrared spectrum and the red edge, if you look at that stuff in the spectrum, you can tease out a lot more information about plant health. So you're looking more at nitrogen and chlorophyll, some of those things. So now if we get into some of the analysis side of that, anybody can go up and fly this data, but what do you do with it afterwards? Like, okay, yeah, it looks red and green. So there's some analysis that you have to apply to it after you collect the data. And that's where we've got the imagery side of the triangle. Now, if we look at more of the analysis, I put up these 4 slides or these 4 pictures, A, B, C, and D, to say, okay, if you're walking around in the orchard there and you look at these, can you tell which areas are doing really well and which areas aren't doing so well? So keep that in mind for now. We'll come back and visit this later after I explain a couple more things. So when we look more at the data collection and the analysis, the way you're looking at red, green, and blue data, this is from the visible bands of the electromagnetic spectrum, you're getting a red, green, and a blue value. Each one of these pixels is going to give you a combination of red, green, and blue. So if you're looking at multispectral imagery, you're not getting the red, green, and blue. You're also looking at near infrared and red edge. And what that tells us is if you're looking at very healthy vegetation, it reflects very high in the near infrared spectrum. But you can't see that with your eyes because we're human and we're just, we're not very good at that. So the healthy leaves reflect very high in the near infrared. Stressed leaves, they have a lot lower near infrared and also, sort of a normal level of green. And a dead leaf just shows, low reflectance for everything. Now, you might hear like, okay, well, what is a vegetation index? And a lot of people have heard of NDVI, right? That stands for Normalized Difference Vegetation Index. It's something that's been around basically since the 70s. And it's very good at detecting sort of a broad range of, is it vegetation or not vegetation? So this is something that they've used for a long time to detect like forest loss in the Amazon and other places where they're doing a lot of slash and burn, stuff like that. But there are some problems with NDVI when you get into more, higher level of detail imagery and analysis, because it tends to oversaturate in closed canopy. So you kind of have to think about what your structure of the area that you're trying to map is. Is it a monoculture? Is it a well-maintained orchard? Is it row crops? And so all of these different structures might have different vegetation indices that you can use. So to show an example of the difference in the analysis of NDVI versus NDRE, this NDRE stands for Normalized Difference Red Edge. So it's similar algorithm, but it's showing you a little bit different information. So this is the NDVI. And that's showing that, all the stuff that looks green, that's like 84% of it is this darker green color. So it looks really healthy, right? But if you apply a different vegetation index to it, the NDRE, you can see how much different that is. Now it's showing only about 22% of that area looks like it's really healthy. And this is a notorious problem with NDVI. So you can't just kind of run a vegetation index on this data and assume that it's going to tell you everything you need to know. There's a lot of things that you have to check, and you might need to check other vegetation indices as well. So in order to get to this kind of classification and something that you can quantify, you have to do some additional processing, because if you look at the veg index value, when I run this one, your values typically are going to be from -1 to 1, where 1 is your highest value, -1 is your worst value. So what you need to do is, if you click on any one of these pixels, it'll give you a value that's somewhere between 1 and -1. So if it's somewhere like around 0 or in the negative numbers, you're looking at something that's dead. If you're looking at 0.4, 0.5, the closer you get to 1, the healthier the vegetation theoretically is. But in order to make it quantifiable, I had to classify these things so that you're breaking it up into, I just did 5 different categories. That way, once you have them broken down into those 5 categories, you can calculate the number of pixels that are healthy, the number of pixels that are unhealthy, dead, and then you can create a percentage of the overall. And the other thing is, there are other issues with that. If you're going to run the whole thing on this whole orchard, you're also looking at holes, you're looking at potentially non-production areas. So you can see that's why I created these other things that show, just the yellow areas, the area that's in production, and holes. So I exclude that stuff from that type of analysis. And one of the other issues, that the slide that we just looked at before, that's a really dense, MacNut orchard. It's older. It's basically a closed canopy. But what if you're looking at an orchard like this, where you've got a lot of soil and stuff showing through on the edges or in between trees? Well, if you run that same kind of analysis, you can see that you're getting a whole bunch of red and stuff that looks like it's dying in between the rows. So you can't really just kind of quantify the whole thing. You have to individualize it. So the first thing I did to keep it really simple was I just created a series of polygons that, these circle polygons that are generally the size of the tree that I'm trying to analyze. And then I filtered out everything that's not inside those polygons. So once I extract all the pixel values from inside each one of those tree polygons, then I can categorize that as, give it a health score. And, this is kind of an old presentation. I've gone in a lot further than this, and I've used some R programming to automatically detect trees and automatically put a polygon around the shape of the tree itself. So you get a much better agreement. Like this one here, you can see it's underestimated. There's a lot more tree there than the size of the polygon that's there. So if you're looking at the infrared data, it's showing that a lot of these trees are in decline. And we know that they are. If you talk to anybody that's in the macadamia orchard industry, they'll tell you we have major problems with Phytophthora, we have problems with felted coxid, we have problems with, all kinds of things that the MacNut industry is really suffering. So you can see a lot of these are already sort of like browning or even, kind of dead. So how do we monitor this situation over time? If you're going to try and do some kind of mitigation, are things getting better or are they getting worse? So I did this this is 2020 compared to 2022. So as you see this thing moving across, now the trees that might have been healthy in 2020, a lot of them are dead in 2022. So you might need to try and figure out, okay, where are the areas worse and where are they, not so bad? Let's try and figure out what the problem is. So you're not just kind of like randomly going out and, looking at trees like, hey, there's a dead one. Like you can actually put some spatial analysis to this and try and approach it with science. So it's not 100% gloom and doom all the time. This is a change detection that I did. So from 2020 to 2022, I decided to see, okay, well, how many of the trees are improving? How many of them haven't changed at all? And how many of them are declining? So if you look at the sequence I showed you before, it looks like, oh man, we're not going to have any MacNut trees left, in the next 5 or 10 years are all going to be dead. But if you look at this image, you can see that the ones that are white are actually ones that improved in health. So there's some stuff that's improving here, some stuff that's improving over here and down in here. This is the area that I showed you on the last sequence, this area and this area. So there's clearly a problem in here. But overall, there was, more than half of it didn't change. And, 29% of it was in decline, which isn't good, obviously, and only 16 improving. But in order to be fair, you can't just say, hey, these all died. You have to run a detection to see like what's good and what's bad. So some of the other stuff that you can do with that, identifying invasive species, you can see up here on the top, the resolution is good enough that you can see, oh, that's clearly not a MacNut tree. So when you see that stuff, you can pinpoint it, you know exactly where the latitude and longitude is, send somebody out, take care of it, get rid of it. You know, if you've got 6,000 acres or, you know, a 4,000 acre orchard, and you don't really, it's hard to keep up with where these invasive species are. So that's another thing that we can use there. I already talked about, you know, doing some measurements, the actual production area as opposed to the whole area of the orchard or the orchard block. So any kind of area analysis that you want to do, and also, of course, tree counts. I mentioned in the beginning, they didn't even know how many trees they had. So this was a tree count that I did, and these were also symbolized by, you know, trees that looked okay, ones that weren't so good, and ones that there was either a hole, there's a missing tree or a dead tree. So the other thing you can do with this stuff, it's not just looking at top down. You can also do more of a 3D kind of analysis. This is some surface modeling. It's not, photogrammetry isn't actually the best tool to use for getting ground models. Really, LiDAR is the best for that. But if you have to use it in a pinch, you can usually kind of get an idea. So this is a digital surface model that was created from all of the overlapping images. And in the end, I created you can create, you know, some runoff hydrological kind of analyses. So this is a digital surface model without any manipulation. So you see all of these little kind of like broccoli head looking stuff. That's all the trees that are in there. But then if you kind of scrape the trees off and you look at just the stuff that's on the ground, then you can kind of see a little bit better what the shape of the area is. So you can create contour lines and stuff like that. Some other stuff you can use it for if you're looking at new areas that you want to plant. You know, if you're whatever kind of crops or trees or grasses or whatever you're trying to do, you can do an analysis on these new areas as well. So you can do cut and fill type analyses. And this one, all of the areas that are red, you would need to cut, maybe if you wanted to make this perfectly flat and in line on the slope, you'd need to remove about 3 million cubic feet of soil from those red areas and place it in the lower areas that are brown. You can do kind of slope analyses. So this is an old sugar cane plantation, as you know, would probably be obvious to most people anywhere in Kau. So they had created all of these kind of water bars and stuff on this slope. So I just did a slope analysis because we didn't want to put any trees on slopes that were steeper than 20 degrees. So one of the other things they asked me to do was they said, hey, we're gonna bulldoze this whole area because it's full of invasive species. It's not worth trying to save the Macknut trees. We already, you know, replanted this section here, but what we need to know is how many seedlings do we need if we're gonna use a specific spacing and we're gonna use a specific planting pattern. So it's another quick and easy way for you to save time and money by figuring out exactly how many seedlings you need to order or seeds, or, you know, how many you need to plant in your nursery. So some of the field work that I wanted to touch on, we're coming back now to this, these 4 photos, right? I actually went out there, I was walking around, taking photos, and this shows the track of where my GPS receiver was showing where I was. And so 2 of these pictures are in this area here, and 2 of them are in this area here. But I'm not sure if anybody out there can tell me which one is which. So when you look at it in 3D instead of just a top down, you can clearly see on this one, like, oh, well, you know, there's a big drainage coming through here. So obviously this stuff is getting a lot more water. Or maybe it's also, you know, the fertilizer is running off and, you know, going into these areas. These trees look pretty good, but what's going on in this area here? And we don't really know. So, you know, you might need to go out there and do some soil testing or figure out what the problem is. So when you're out there in the field and you have GPS and you have, you know, your location turned on your phone when you take photos, you can pinpoint exactly where those photos are. So this photo here was taken right there in, you know, the middle of this area that looks pretty rough. So I'm not sure who guessed A and B were poor health and who guessed C and D were in good health. But if you got it right, congratulations. So, but if you're walking around in the orchard down there and you're just looking at this stuff from the ground, would you really anticipate that this area here is, walking around down here, can you tell if you're like the treetops are showing really like negative, they've got a very poor health score according to the multispectral imagery. Some other scouting tools, you can also go out there and collect video. And while you're looking at the video, you can put it side by side on a map and show exactly where the drone is flying. And then this is the window of your view of what you're looking at. So if you pause it and you say, hey, look, this is there's some yellowish looking stuff here. And sure enough, you can see in the multispectral imagery that it's also showing you that, yeah, there's a problem right there. Let's go figure out what it is. So there's all kinds of different tools that you can use for examining your land and doing different types of geospatial analysis on that. The other thing that you can do if you're crowdsourcing, we had a couple of people going out into the orchards, and they were collecting data on their phones about different issues, like if there was dead trees or things that needed to be trimmed up. There was a lot of suckers that needed to be removed, bad drainage, stuff like that. And this is kind of fun because you can actually sit in the office looking at the map and watch them, drop breadcrumbs of data. And once you have all that data into your maps, and it's basically real time. So what you can do is you can create some heat maps and show, okay, well, if we need to go out there and, focus on cleaning up some dead branches and stuff that's, getting in the way of harvest, where should we focus our energies? So this is a heat map showing, where the areas are that you should probably focus on the most for branch cleanup. So where are you all in your spatial data continuum? Are you still using paper maps? Are you looking at satellite imagery, or are you going all the way and looking at multispectral imagery, or even using LiDAR and for your topographic analysis and hyperspectral for geology, or even identifying individual species in a mixed forest, stuff like that. So that's what I had for that presentation. I could talk for hours about this stuff or anything else. I actually don't even work for the macadamia orchard anymore. I'm currently working for the county. So I'm doing a lot of analysis on things like Waipio Valley Road and some of the more engineering stuff that's going on with geospatial analysis. In fact, I could show you an example. Hopefully this is still on the screen. Do you guys see this 3D drainage area, or do I need to share my screen again?
Scott, I think you need to share your screen again.
Okay, I will do that. Share screen, where is that? Oh, here we go. Okay, hopefully you can see this. Can everybody see this 3D point cloud?
Yes.
Yes.
Okay, great. So this is about 250 acres of the Hailea Gulch in Ka'u. So this eventually runs down into Punalu'u in the Black Sands beach area. So all I have right now is the 3D point cloud, and this is a purely photogrammetric point cloud. It's not LiDAR, but we're looking at over 2 billion points here, and each one of those points represents a lat long and an elevation value. So what they wanted me to do is try and get an idea of what's going on with this drainage system, because the LiDAR data that we have for this area is not that great. If anybody else, you geospatial people out there, if you've looked at the LiDAR data that's available for the Big Island, that you can get from the NOAA USGS Coastal Data Access Viewer, you're only getting, 4 or 5 points in something like this with this densely vegetated, canopy cover. So these are the types of products that you get with these technologies. GIS it's an amazing tool to do land analysis. I also created a digital surface model here so you can see a little bit better, in a 2D plane. So now ideally I would have LiDAR data, but the county so far has been too cheap to buy me one. So but when they see this, then I know that they know that they need something that's going to give them the results they're looking for. Because I can't really scrape off all the trees on this one to get a real good elevation model. I mean, it looks pretty good, right? But ideally you'd have LiDAR. So that's a surface model. I've got all kinds of other stuff I could show you, but I guess I'll leave it there. If anybody has questions, or you want me to show some more stuff, if we've got some more
God,
time.
thank you, thank you, thank you. I'd like you to stop because I think there are probably lots of questions, and I want to give these nice people a chance to throw what I'm sure is in their heads out at you.
Perfect.
Well, that's quite a response.
I have a question,
Sure.
and this is regarding crop insurance. Macadamia is covered with RCIS crop insurance. You can make claims against tree death. You can make claims on nut loss, and this is a significant amount of money that is at stake when you make a claim. It's a federally funded insurance program. The company pays in a certain amount, and then the feds pay in more. But I can see that if we get the insurance adjusters involved with this technology, we would have a much better way of accurately reporting tree death and potentially nut loss, which would be a compensable claim. So something you can work on with HMNS or Olson Trust.
Yeah, that's the idea. I don't know if there's a question there that I can answer, but yeah, I am aware of the insurance that they have and they take out. So I was showing them, an analysis of all these orchards. I didn't have an analysis on every orchard, but some of when they were concerned about certain blocks, then I would go out and do a more robust analysis on those. In the beginning, it was just kind of trying to get a baseline because they didn't have any baseline data about exactly, they didn't have a snapshot of what they had now. I mean, they knew that they planted in the 40s, and they've been harvesting ever since, and they've done some replanting, but I don't think they really knew any kind of baseline information. So
yeah, our insurance adjuster is coming over in the middle of the month to meet with all of us, and I'm going to bring this up.
that's good.
I have a question, just out of curiosity. So are you aware of any efforts utilizing all this technology to help us be more effective in dealing with invasives, especially from a pest perspective? There's a lot of word right now about the rhinoceros beetle infestation, for example. The ability to maybe detect earlier when there's an infestation sooner than seeing a tree die. I'm just curious if you're aware of whether or not this is already being utilized. It seems very powerful.
I have seen a little bit with the rapid ohia death. There's a researcher here whose name is Asner.
Greg Asner. Yes.
Yeah, Yeah.
University of Arizona.
Right. So he's he's basically based here on the Big Island. I think he's in Muliti, but he does a lot of work with hyperspectral imagery, and so I know that he was under contract, I think, or there was at least some effort going on with the rapid Ohia death that they were using some of this technology for that. Yeah. Other than that, I haven't really heard that much. I mean, I really tried to get it going. That's sort of what that presentation to the Macadamia Nut Association was geared towards, is trying to make people aware that they could use this for stuff. But farmers, they get into that. They're in their day-to-day grind, and they're not necessarily thinking about some of these things, and then when they do, they think, oh well, it's a lot of money, or it's a lot of effort. We don't have the time or the resource to do it. So that's kind of what I was feeling. I was getting the sense from a lot of the other macadamia nut farms that I talked to.
Scott, you didn't cover one thing in your presentation that was exciting to me. You and I discussed, and again, it's premature. You discussed how you could use AI to overlay imagery to demonstrate how a piece of land might be improved over time under different conditions with intensive management.
Yeah, you can. Yeah, there's another. Let me show my screen again real quick. I think I might have actually showed you this one. Where's that? Okay, so this is like a hydrological analysis that I did for one of the roads in Hilo, and because there were a lot of driveways going across this drainage ditch, the flow wasn't actually flowing where it looked like it was supposed to be flowing. So you can do something that's called terrain painting, where you can kind of manipulate the surface and show. Oh, that's not a very good one, and I don't know if you see that window or not either. Okay, I'm not doing very good with these on the fly presentations. But anyway, you can yeah, it was kind of like the cut fill thing that I showed earlier, but you can also if you have a surface model like this, you can show different changes. Like this one, if I zoom in, if I put that in 3D, you would see that the surface model shows the elevation model with a big, basically like a dam right here. But you can use these tools to, cut through that dam essentially and show how the water would flow. So you imagine if you were looking at, if you were looking at a mountainous region that had, a reservoir or something, and you wanted to see what would happen if you cut a different channel going into that area. You could do that and make models to show what what the before and after would be, or you can do like flood analysis and all kinds of different stuff like that.
Yeah, seeing some of the topology, sort of mapping, it occurs to me like days after Hurricane Lane landed here, I looked over the edge and watched this kind of near chocolate brown Wailuku storm down the slope. And I've recently looked at a YouTube where a PhD documented this was in Arizona or New Mexico, two identical, well, roughly geologically similar drainages rather. One, the owner put small stacked stone across, drainage, and it slowed the water down. And what they found is that the drainage that had, these many small, I mean, they weren't dams by any chance, but they retain the water. It it was kind of night and day with overview. Uh, One, how slowing the water down allowed the water to soak in and disperse. But if you're in a situation where you have an orchard and you're applying inputs, that's during our, at least a harsh rain, all these inputs don't run off into the ocean. They stay in the orchard. So I see application immediately with using tools like this to perhaps put some of these small structures in to actually um, vitalize, make it healthier.
Yeah, there's a lot of different applications. I mean, and it depends on what you're looking at too, if you're looking at row crops or if you're looking at orchard crops or if you're looking at forestry applications. There's like you can think about whatever you're thinking about. If there's a question of where and how to improve it, you can pretty much apply some kind of geospatial tool to it.
Yeah, I mean, water is a resource, and it's controlled by the state, and we seem to fight about it all the time.
Yeah, I think that's why they want to do a lot more mapping of the drainage systems. Um, there's a big effort right now with the county to even map all of the culverts and the catch basins and the dry wells and things like that, because that stuff is all just sitting on in paper files and file cabinets, so we've got a bunch of people out in the field now that are going out there with iPads and they're collecting all kinds of data for all these different drainage features. But they also want to map the ones that aren't really in the cities. They want to map the ones that are washing out bridges and stuff too in the more rural areas.
Yeah, data retrieval. I've kind of been in that business in aerospace, and you'll have a younger engineer come in and it's like, oh, we should study that. It says, yeah, we did 20 years ago. So, well, okay, where is that? Well, it's in this file cabinet over here. Well, until they actually digitize everything, now you can get to it.
Yeah.
There was some scenes that I saw with Hilea Gulch. You did that drain that came down from the old Kane Road in Ka'u. From about that area of Ka'u going south, we have a major flooding issue. Places are flooding there that have never flooded before. Highway 11 is getting covered in mud and water where it never used to before. And I got the NRCS to fund a study, the Ka'u flood study, because I'm chairman of the Ka'u Soil and Water Conservation District, and we got $50,000 allocated for it. Well, guess what happened to my money? It got deferred. So I need to find out where the channels are being blocked by albesia trees, cat's claw, or other invasive species that have come in and altered the flow of water to where the channels, it's cutting new channels through the land. And this is a serious issue. And I think we might have a tool in this drone study that is really going to help.
John, just to piggyback off what you said, again, if you expand what you're saying to being able to map out all the apua'a, all the watersheds, and be able to manage land with that in mind going forward, think about the opportunities that we have not only to organize land and food, but to organize people so that they understand what watershed they're functioning in. So the opportunities are amazing.
Yeah, very much. I have a cultural thing I'd like to add. In your Hilea Gulch video, you came across a kuleana owned by the Hanoa family. Plantation never owned it. From the beginning of the Mahele, the Hanoa family has owned this kuleana, and the plantation never grew cane on it. It's there all by itself right off of Hilea Gulch. And you flew your drone right over it, and I could see the kuleana, the the cultivation grounds of this old Hawaiian homestead. And the family of the Hanoas would absolutely be astounded if they could see portions of your drone video of Hilea Gulch.
Yeah, I'd be happy to share it with them.
Yeah, I mean, land ownership. We got these Hawaiian kuleanas that have been out there since the 1847s and all that, and some of them have been hidden away, locked away by weeds and albijas. And I just saw a kuleana in your video that was like, oh, there it is. I see it.
Well, the thing is with that, I explained how the drones are a little bit limited in that, to actually map out all those drainages. So what I propose to do is to combine the drone data with terrestrial scanners. They're these scanners they're based off of LiDAR systems that you can put on like a backpack or on the hood of a car or something, and you can just like walk through that area, and then you can get all of the data that you need underneath of the trees as well. So you can get a really good ground model that way. So if you combine that, kind of terrestrial scanning data with the UAV data, then you could produce something pretty useful, I think.
Yeah. Archaeology. It's from a drone. Yeah.
Yeah, they use it a lot in archaeology.
What I was hoping Scott was going to do, because I think you guys all know I'm really focused on trying to get Hawaiian Acres to be a demonstration project for small scale cooperative private agriculture. And if we could map out all of the hydrological events on all of the roads in Hawaiian Acres so we can understand where the total water is flowing, I believe we can develop the roads so that we can put in a series of gate valves or whatever to really um, manage the water, to avoid road washouts, and to, as we're entering periods of drought, to maximize the roads as culverts to move irrigation water into different properties.
Hal, you were about to say something? So you,
I was going to ask if you can use this system to map out soil moisture content.
They do have sensors that will allow you to do well, it's like a vegetation index, but it's a moisture index, and you need a sensor that includes thermal data.
Thank you.
Sure. Those are actually getting relatively cheap too. I don't know the quality. I haven't really done much with the thermal data, but even the drone that I used to fly that Hilea Gulch in Ka'u, there's a sister sort of model to that one that also includes thermal. So I think the price range is getting a lot better. Before you had to have these really big, heavy, FLIR systems that went on heavy lift drones and stuff like that. So it was kind of cost prohibitive, but the price is really coming down a lot. People are using that also for, solar panel inspections and things like that to see if you've got bad cells.
Scott, would you be able to send us your contact information?
Yeah,
Because
absolutely.
I know the Hanoa family and they'd love to get in touch with you.
So I just put my email there in the chat. And there's my phone number. And my website. It's not very updated, but I'm working 2 full-time jobs, so I don't really have a whole lot of time to work on that website.
Well, Scott, thank you so much. This has been very informative.
Yeah, thanks for having me. I wasn't sure if I
Indeed.
was going to be able to focus on, sustainable energy. I live that way. I live off grid. I was a Peace Corps volunteer. I, worked for Park Service and Fish and Wildlife and Forest Service, and I've always been passionate about sustainable energy. I just don't really have a presentation that's focused on that. So
Well,
thanks for giving me the time.
no,
Yeah.
what's very clear though is that you've introduced us to this space, right? All these different technologies that can be used to better understand the environment, and obviously, as we're looking into all of these alternatives to fossil, there is an opportunity for us to create synergy with how we use our land. Agri-solar is an example, and when we talk about biomass, optimizing the use of lands so that we can actually achieve our energy goals and also our food security goals. I mean, they're all intermeshed. So this technology that you've socialized here, I think, brings up quite a few ideas and maybe a lot of questions too. So thank you.
The question, Hal?
Yeah, Scott, I'm very pleased to hear that you were a Peace Corps volunteer. Where at?
Yeah, I served in Kenya, in a place called the Taita Hills in Mombasa, and my partner was Peace Corps in an outer island in Chuuk in the Mortlock Islands.
Uh-huh. I was Peace Corps in Thailand in 64 and 65, trained for 3 months in Hilo on the Big Island at the end of 63.
Very
And
nice.
it's a small world.
Was that you must have been group 1 or 2 then?
I was group 7 to go to Thailand. Yeah.
Okay.
60, we trained from in the last 3 months of 63, and then we went to Thailand January 64. And so I was there
Fantastic.
64, 65. And it was what opened up my life. I would say everything I did after that came from that. First
I
job
feel
being a Thai interpreter for the State Department in Washington, because in 65, 66, they didn't have any.
right. Yeah. I feel the same exact way about my Peace Corps experience. It really you know, put me in a direction that was the way I went the rest of my life. It's no surprise to me
Yeah.
that you also have worked for the UN and then to, lots of
Well,
other countries.
my UN office was the UN Center for Human Settlements, which is located in Nairobi.
Okay, nice. Yeah.
In that big building out there, the Nairobi, they have UNCHS and UNEP,
Yeah, UNAP.
UN Environmental Program, are all there. They share the building, the campus there.
Yeah.
So thank you very much.
Yeah, thank you.
Cool.
Well,
Yeah,
this has
thanks,
been
Scott.
great.
That was a great talk. Appreciate yeah, you giving us that demonstration. Very fascinating. So yeah, thanks.
I'd be curious to hear more from you, geospatial people. If you're using this stuff, I mean, it's not super new. I mean, it's been around for a while. So I'm wondering if the other
Yeah.
geospatial people are doing, similar things.
Yeah, we have lots and lots and lots of LiDAR data here in the state of Washington. We have a pretty vast database, and I went over there to Hawaii and I looked at the old map department, one of the city officials, and he pulled out the big chart from one side of the room to the other. That was the original zoning maps. And I was shocked that none of it had been digitalized or really online anywhere. And I mean, this building, it looks like one of those ones that could go down any day now or whatever. But it's yeah, it does. It seems like a great tool to be using on the islands. And I think once it gets more traction and there's more coverage and data, I mean, I think yeah, whoever gets behind it, they're gonna be doing great. So
Yeah, and it's not just the drone either. It's just, geospatial analysis as a whole. And, since starting, I've only been working for the county since January, but I'm the first GIS analyst the Public Works Engineering Division has had. Yeah,
Nice.
it's
Yeah.
like it's dumbfounding to me. Like, how did they
Yeah.
not have a GIS person before me?
Yeah. No, it's wild. Geez, that's cool though. You're really creating the culture there.
I'm trying to push it as hard as
Yeah.
I can.
Well, cool.
Yeah, thank you.
Yep.
Any other questions from anybody? No, this was very cool. And whether energy related or not, absolutely fascinating. And as Gary knows, energy spans includes food, and that's where we get our energy. And being able to maintain that is how we sustain ourselves. Well, is it Pau Hana?
It is.
Well, thanks again, Scott.
Thanks, everybody.
Thank you very much.
Yeah,
Yes,
Thank
thank
you.
thank
you,
you very
everyone.
much, Scott.
Really great talking to you guys. Thanks for giving me the time.
Have a good
Thanks,
weekend.
thanks for coming.
Okay, bye bye.
Aloha.
Take care.
Yeah. Have a good
Bye,
evening,
everyone.
everyone.